My name is Matt Sump. I'm our Illinois and Iowa account executive, and I have Devin Glass, who will be doing most of the presentation today, one of our applications engineers, and also doing training out of our Indiana office. So just a quick overview of the agenda today. It's going to be real simple. I'm going to pass it over to Devin here in a second, and he's going to go over all the different design tips and tricks that we got for you today.
Alrighty, good morning everybody. My name is Devin Glass. I'm the applications engineer over here in Indiana. You guys have probably gone through my class here in the Indiana office. And if you guys have listened in on our last few webinars this year, you probably are well aware of my voice. So today we're going to talk about some design tips and tricks with Mastercam. Most of these have been in Mastercam for many years, but there's a handful that are brand new with 2022. And of course, I'll make that hopefully as clear as I can, that when I talk about a feature, whether or not it's been here for a while or if it's brand new with 2022. Unlike probably our last few webinars where we kind of talk about, just 2 or 3 parts or 4 parts or so, with design specifically, there's a lot of more application specific and more model specific features here. So we're going to be jumping around from file to file to file to file. So hopefully I don't lose you there. We're going to start off real nice and easy. We're going to talk about wireframe and editing wireframe and whatnot, and then we'll move on to more complicated stuff. So first off, I'm going to open up a print that it's actually a drawing exercise we do. Of course, I got to find it. There it is. So this is part of a drawing exercise we do in our normal Mill 2D class. Unfortunately, due to time constraints and our primary focus being more related to machining and tool pathing, we don't always get to it. But there's a couple of features on here that I like to show off. The biggest one that I wanted to show in this webinar is what's called relative point position. So I have the print here that we normally draw, and I've drawn most of it here. And this is the print, and all I'm really missing is this center groove right here, where it's about a 4x2 with a 1/2 inch radius on the corners, and it's centered up, and it's from the bottom 3/4. Now, traditionally, what you'd have to do is, you would do wireframe, rectangle, and you'd manually type in the coordinates with fast point, which is something we talk about really early on in our 2D class and in our lathe class. But here I want to show you another trick. So under the wireframe tab, I'm going to go underneath rectangle here, because I could do just a normal rectangle, but there's actually another tool that makes my life a lot easier when it comes to the origin position and putting corner radiuses on it already. So that's rectangular shapes. And I just want to do a rectangular. I want to do a base point. And then the origin determines where this rectangle is being drawn from. What is the origin of this rectangle? And I'm going to pick the bottom center here. Just going to make my life a little bit easier. Then I'll just type in the information. So according to my print, it's a 4-inch wide pocket. It's a 2-inch tall. And then the fillet radius is going to be 1/2 inch. If I move my cursor on my screen, you can see it's giving me a little preview. And wherever my cursor goes, that's where the bottom middle of my rectangle is. Now again, like I was saying, I would have to figure out what the center of this part is by doing some math or doing midpoint with a fast point system here, trying to figure out what the length is, divide that by 2, then figure out the height based off the y coordinate. When in reality, all I have to do is, if I know it's relative to a specific point in space, and I can do this on any function that's asking me for a specific point. If I hold the Shift key and click a point in space, such as the midpoint of this line right here, it brings up my dynamic gnomon, and this is entered relative position mode. So at this point, I can look at my print, and it says, okay, it's 3/4 inch from that line. So I just click on the Y shaft, and again, guys, if you're used to the dynamic gnomon, whether in dynamic plane creation or dynamic transform, this is very similar. And I can move it up 0.75. If this is still new to you here, if you're off the ruler, it's wherever it is in space, so 3.63458. If you're on the ruler, it's incremented by a set amount, depending on how closely you're zoomed in. So here, I'll just, I can also type 0.3 or 0.75 as well, but I'm just going to find 0.75 on this ruler. I'm going to click. I like where it is. This is my opportunity to move it in X if I need to, or rotate it if I need to. I'm just going to go ahead and hit the Enter key to accept what I got, and bam, there I go. That's my rectangle. I green check, and now it's in the correct position. But this works for any time you need to select a point in space. So say, for instance, I'm wanting to draw an arc, and I want it to be, say, a 1/2 inch arc, and I know it needs to be, relative to this midpoint. I can shift click, brings up that gnomon. I move it up or down, maybe up 1 inch, and then I move it across an X in 0.58, or I'm sorry, 0.58, 5/8. I hit the Enter key to accept what I have, and that's where my hole goes. So again, something we don't get time to usually talk about. I sometimes try to show you guys that you could do it in the very beginning of the class, but don't get a lot of time to really dive down deep into it like I do here. And that's been around for quite a bit.
I didn't even know that was a thing, Devin.
You didn't know about that, Matt?
No. You learned something.
I use it all the time. The next big feature I want to talk about with specifically wireframe is was added in 2022. So this is one of the few ones I'm going to talk about today that is only 2022. But if I need to change, like say, the diameter of this arc here, if I need to change the diameter of this arc, oh, hold on, let me, so I don't get a bunch of emails. I meant to do this before. There we go. No distractions. So let's say I want to change the diameter of this arc right here. Before in older versions of Mastercam, what I could do, and I could still do this, I can click on the arc, right click, analyze entity properties, and then I could change the diameter right in here. I could change the radius right in here, or I could change the position right in here. Well, in 2022, what we can do is what's called surface level editing of wireframe. And I can double click on this arc, and that gives me a bunch of controls, bunch of on-screen controls. First being the radius. So this blue arrow right here is determining my radius. So in this case, it's saying it's a 1/4 inch radius, but I can click on this arrow and I can expand it, contract it, expand it, contract it. And again, if I'm off the ruler, it's wherever it is in space. If I'm on the ruler, it's incremented. And of course, like I said before, I can actually type something in. So if I wanted this to be a 3/4 inch radius, 0.75, enter. I like what I see. I hit enter again. There we go. I can also control the sweep of this arc. So the start and the end, get the sweep. I'll go ahead and make it a 360 again. And I can also change the position of this arc. So if I grab the gray center here, I can now move the origin, move it to wherever I want. I can move it. Again, I'll use that shift click. Say 1 inch from the top there. Like where that is, I hit enter. There we go. And you can also copy it. So if you hit this little minus icon, that'll switch it to a copy mode. And now when I move this arc somewhere else, it's just making a copy of that arc. And then if I want to edit this one, I just double click on this one or just single click it when I'm still in surface level editing. And now I can edit this one as I want. This isn't limited to arcs, however. This can also work for lines. So if I say double click on this line here, I'll go into surface level editing. And again, I can click this little minus sign to turn it into copy mode, and then I can copy this wherever I want. I'll even edit this one. I can move the end points and start points to wherever I want. So I can move the start point to like this point right here. I can move the end point to like this center arc if I wanted to. And actually, one of the functions I didn't realize was a thing until the other day when I was testing this out. But if you hover over one of these endpoints, an arrow appears, and now you can extend that line by a set amount. Which that one I didn't know about till I went to prepare for this webinar. So, and again, if I hover over the green point for a second, the green arrow appears, and now I'm extending this line by a set amount that way. So if you wanted to extend something, you can go for that. And you can also use it for points. So if I have like a point in here, I could double click on that point, and really you can only change the position, either move it or copy it. There's not really any other things you can do with a point, just by the nature of it being a point, but I can grab it, move it somewhere. And again, if I grab it, I can hold the shift click on the point itself. So if I know that this has to be like 2 inches to the left, I can grab the axis of this, move it 3 inches to left, enter, and there it is. And then when I'm done with surface level editing, as the command prompt says, I can hit the escape key, and that gets me out of the function.
Hey, Devin, a quick question that Elliot had that I thought was pretty good. If, say you have a group of lines that technically make a rectangle, can you select them all and edit it?
No, you can't. If I'm understanding the question there, Elliot, if you're wanting the rectangle to update in real time here, we can't do that. So I can't like stretch this line up and then the rectangle updates with it. I can only do this with one line at a time, and then I have to
Yeah, you use
come
like
through here and pick
join
the other
entities
two.
or something like that. Yeah. Okay.
Yeah, you have to do join or move it like that.
Got
So
it.
unfortunately, we still can't grab a rectangle after you've created a rectangle. Of course, if we were in the rectangle tool, we can still adjust the width and the height in here, but not in the case after you green check out of here, because these become 4 lines at that point and they become completely independent from each other. Another thing we can do here, I'm just going to real quickly talk about, it's something I try to talk about in class, but sometimes I just don't get a chance to talk about it, and that is what's called temporary midpoint. And now, guys, I've seen a lot of people run into the situation where they're trying to draw something, and let's say they want to draw an arc between this point and this point right here. So I'll use the control key to highlight those. They want to make a point right in here, but between these 2 points in space. Well, if you guys ever notice when you hover your mouse over a specific point, a little green plus appears. At first, nothing happens there. But if I go over another point in space and hover over that for a second, another green plus appears and a red plus appears between them. That's what's known as temporary midpoint. And then I can now come over here, click on the red point, and that's the perfect midpoint between those 2 points. So if I said I wanted to get the midpoint between this midpoint and this midpoint, get that. I could also do something like this. I could say get the midpoint between this point and this point. Get that. That's what's known as temporary midpoint. So you don't have to create geometry there just to find the middle of 2 specific points in space.
There's a setting in the configuration too on how long the delay is for that, right?
Yep. You can set the delay. So if you want the delay to be a little bit longer, you want the midpoint to be, I think there's like even an instant mode, but I haven't really tested to see how natural that feels. But yeah, it's like only I think it's only 1 Mississippi. Yeah, it's about 1 second. All right, guys. So I'm going to jump into. Oh, I think I see another question from Elliot there. Can you go between arcs? Yep. You already got it from me, Matt, there. We could do it at any auto cursor position with the green point. All right. So, guys, I'm going to move on to another file here. I'm going to talk about a setting or a feature that came about in, I want to say, I think it was 2019. Mastercam 2019. Oh, and I almost forgot to mention, temporary midpoint's been around for quite a while. So again, I think it was even in the X series. So if you're curious if you have that or not, rest assured, temporary midpoint's been around for a while. Quick plane has been around, I think, since 2019. But to kind of give you an idea of where this came from, because no idea comes from a vacuum, we had a couple customers who do a lot of design work in Mastercam where they want to create a feature right on, say, this face here. So what they would have to do is they'd have to go into the planes manager, create a plane off that solid face, and then create their geometry, create a plane from a solid face, pick this solid face, create the geometry. And what would end up happening is every time they went to draw, say, a circle, they would have, 4 or 5 different planes for each orientation of that circle that they had to draw. So in 2019, they introduced what's called Quick Plane, and I used it so often that I kind of put in my right mouse click for a while, but unfortunately, I reset my defaults to for the webinar here. But under the green plus and planes, we have quick plane, and it works just like it does for from solid face. The only difference is we're using what's called what I would call a temporary plane. When I click on this solid face, it now locks me in on that and makes my construction plane. So now when I draw a circle, it's in that view. And then I want to make another quick plane off of this face. If you guys pay attention to my planes manager here, when I create a new quick plane, it does not create a new plane. It just keeps using that same plane. So this is what I would call a temporary plane. I could then, draw a circle. I'll use temporary midpoint to get, like, say, use temporary midpoint to get, say, the center of this arc. Hold for a second. Center of this arc. Hold for a second. Get the midpoint in between them. And of course, it's below the surface. I'll switch it to 2D and do the same thing. Hold for a second. Hold for a second. There we go. So that's the midpoint of, or the center of these bolt hole circles. And again, I can make another quick plane. And it's just using that quick plane over and over and over again, and it's temporary. So when you go back to using your top plane or any other plane that you're using, after you save and close out Mastercam, this quick plane disappears. And you cannot use a quick plane for tool pathing. Now, that being said, if you decided you do want this plane, you do want this quick plane to be a normal plane, you can always right click on the quick plane and say duplicate, and that will switch it to a permanent plane in my mind, or is how I would describe it. So again, this is just for those people who just want to create a plane real quick, draw some geometry, but they don't intend to use that plane for anything else, and they just don't want to clutter up their planes manager. Now, as machinists, we are used to, in at least 3+2 machining or 3+1 machining, we're used to keeping those planes and using them for tool pathing. But for a designer, you may not want to clutter your planes up with just plane after plane after plane. You just might want to throw something on the surface of that solid and roll with it. So that's quick plane. Again, it's a very small thing, but I use it quite often when I just want to throw a feature on what I'm just designing from scratch, designing parts. And that's pretty much it for kind of wireframe associated. Of course, we're going to talk more about other wireframe stuff, but I'm going to move on to kind of drafting related things. Now, we're not going to get super deep into drafting. We're just kind of focus on some of the quick tools we have at our disposal. But I'm going to open up this right here, solid layout. So a few weeks ago, actually it was probably about a month ago or two, we had a lot of time. We got really we sped through the 2D 3D class, and we had some extra time on our hands, and the questions that the class was asking was I didn't really have a good part for. So what I ended up doing was I created this little part from scratch the night before, and we talked about it. So this won't be the last time we see this part come up, but let's say I wanted to make a print out of this model. Well, when you have a solid like this, one of the things you could do, and I'm going to go ahead and create a new level just to make sure we don't have any conflictions here, even though it's going to make its own level, but getting ahead of myself here. In the solids tab, we have what's called layout. And layout is going to take a solid and it's going to give us our traditional views for that solid. So, I'm using this solid. It's the only solid visible, so it assumes this is the one it's using. You can see here I'm using a template file to determine the boundary of the border of my print. Now, guys, back in, I believe, X6 or X7, Mastercam used to install with pre-made templates of different print sizes. So, I'm using A-inch. There's like A2, A3, all of these here. Let me start over here. These used to be in X6 and X7, and a few years ago, or I wouldn't say a few years ago, about a year ago, a customer reached out and asked, do we have templates for these? And we realized that they never got installed with the newer versions of Mastercam. So what we're going to do here, Matt, or what Matt and I are going to do is we're going to put these on a shared location, so that way you could get these templates and you can use them in Mastercam 2022 or whatever version you're using. I think I updated these to 2020. So that way you can use these standard print sizes and use them in Mastercam. But I say I use one of those Mastercam files as my template. And And then suppress hidden lines, radial display. Scale factor, I'm going to say that's 0.5, so 1 to 2. Level, I'm going to put it on level 1001 apparently. And then I have multiple different layout methods. I have 4-view DIN, 4-view ANSI, 3-view DIN, 3-view ANSI, and so on. But I'm going to do 4-view because there's a couple tools I want to show off in here. So I'll say OK. It's going to warn me saying that there's some associative entities that it can't bring along for the ride, but that's fine. Say it again. Go to top view. I'll go to my levels manager and turn off level 101. And here is just a really quick and dirty layout of my solid here. And I can do quite a bit with this here. So like say, for instance, this view is, in my title block here. So I can say pan it. So I can grab like the bottom of this here, pan it straight up. That'll do it. But now these two are not aligned, which is a no-no. So we could say transform align it. I could say align. This is my reference. And this is the point I want to align up with that. And there we go. So now those are aligned. You can also add different views, but it's already pretty cluttered. But I can add another view if I wanted to. So I can add like a trimetric view if I wanted to of the model, make it the same scale factor. You can see there is my trimetric view. But I'll just put it right there and then I'll remove it because I don't need that there. And we can also add section views and detailed views. So I can say add a detailed view and it'll be a circle. I'll focus in on this, like say this corner here. I'll draw that circle. I'll give it its own scale factor. So I'll say a scale factor of, let's say 1. Might be a little bit on the big side, but we'll do it. I'll place that view right here. And there we go. There's my detailed view. I can also do a section view. I'll do a vertical. I'll select a point. I'll select this midpoint here. I'll make it the same scale factor as the rest of my part. Green check. It's going to ask me to select a position. I'll put it right here. And of course, I can move it if I need to. As such. And once I got my print all set up here and I got my layout all set, once I green check out of this box, much like any other function in Mastercam, once you green check out of here, these become just plain old wireframe. So they become lines and arcs. They have no association to the model. So if I make any changes to my model, these do not change also. So that's something to keep in mind, guys. Once you check out of that layout tool, this is completely separated from the model, completely independent lines and arcs. And if I wanted to put dimensions on this part, so if I go to drafting and I were to make a dimension here, something you also have to keep in mind is right now, because these are just lines and arcs, the scale factor is going to be off. Because if you guys remember, we scaled this down by half, so 1 to 2. And it's telling me that the distance between that length is 3.5. But if I were to measure the actual model itself, the actual length is 7 inches. So 7 inches in X. So in order for this dimension to be correct, what we have to do is we have to change our scale factor. It's very easy. We just come into here. This little drop down. You can also do it from within the dimension itself, but I like to do it in here. And I set the scale factor to 2 because I need to double its size. And when I green check, it's going to ask me, do I want to save these to be permanent? I generally say no because, I want the scale to default to 1. I don't want it to default to 2 the next time I do some dimensions. And now when I draw a dimension from, say, here to here, it now says 7 inches. So it's scaling that dimension up to match the real size of my part. And then using note here, I can say, it was drawn by D Glass. Add that here. I can make another one and call this scale 1 to 2. Add that here. And the nice thing about using notes instead of using just create letters is notes actually can be edited. So if, for whatever reason I need to change my name, I click on that note, I can type in a different name, like sump. I don't believe in plagiarism, so I'm going to put my name back on there.
And Elliot had another question. He says, if you have several solids of different colors, depending on how you made the solid, it will carry the solid color to the layout, and sometimes it will not. My understanding of it is that's controlled by the actual entity attribute, via the right click or the attributes manager. If you use the set feature face color via the model prep tab, that won't come through on the model layout, on the solid layout, right?
That one's a hard one to put because it's gonna bring the wireframe, or it's gonna bring the solid color over based on how that solid has been colored, and it should bring in the model prep change face. But Elliot, if you just circle back with us afterwards, we can take a look and get a closer look and try to answer your question a little bit better.
Yeah, I was just testing that on my computer before I asked you. And yeah, anything I did on the model prep tab with the coloring didn't move over to the layout. Only if I right clicked and actually changed the color of the solid did it work.
Yeah, if the solid is gray, the wireframe will become gray, but I don't believe that the actual change face will come along now that I think about it. So if you change the face color, that won't come along for the ride. In some solids, when you import them in from a different CAD source, while they may appear to be red or green or purple or whatever color that they come in as, that information may have been mistranslated to Mastercam as saying, hey, you have put a coat of paint on top of the model, but underneath that paint, that model is still gray, which might be what you're running into, Elliot. But again, just give us a ring afterwards and we can take a closer look. So again, guys, we'll put these print templates somewhere you guys can get them. Of course, I'm going to have to speak with Matt afterwards about how we would do that.
Yeah, I'll send a follow-up email like I usually do after the webinars, where it'll be a link to the recording as well as any supplementary files we want to supply.
All right, good deal. I assume that's what we would do, but I didn't want to call you out there and make you do more work, Matt.
I got it.
All right. So that's layout. And one big thing with notes in 2022, we kind of mentioned this before, but with solids in particular, we can now create and use notes for design. So if I were to create a note, so drafting note, and I say, let's say it's test 1, 2, 3, and I'll put it like right here. I'll go ahead and use that shift click again. Again, I use this all the time. Oh, I'm in 2D. Oh no, it wants to project, draw that on. Set my Z here. There we go. So I'll make it 1, 2, 3. I'll change my font to be something a little more fancy instead of stick. I'll make it sure. There we go. I can now do a solids extrude and extrude this note. I'll do a cut body, maybe not 1 inch, maybe like 20 thou. Flip the direction. And there we go. And what's new with 2022 is the fact that, one, we can even chain this for solid creation for tool pathing. But what we can also do is now we can come back into that note, edit that note, and make it, say, 987. Nothing happens at first, but if I go to my solids tree, I can see that my extrude cut is dirty. If I just regenerate it, now the solid has updated as well. So that was the big addition to drafting, or I'm sorry, note that hit 2022. Okay. I'm going to move on to another part here. So I'm going to go up to, let's drop down and bring in a new part. So I've had this situation pop up a couple times where, you might still have a manual department where you got some guy at a drill press, drilling out the holes they need to. And let's say this part has already been milled out, or, you just want these holes to be drilled in there, but you don't really need to do it on a CNC. What you can do is you can bring this into Mastercam, and you can see here I went pretty simplistic with my holes. They're all very symmetrical. In the drafting tab, there's what's known as hole table, and again, I'm going to make a new level just to keep things nice and clean. I'm going to do a hole table, and with a hole table, you can grab just a wireframe arc or wireframe. You can grab faces, you can grab edges, you can grab bodies. I'm probably just going to grab the entire body. So I'll just grab the entire body, and what it's going to do is it's going to identify these holes. It's going to first, by default, count them. So you can see here, the A holes are 8. There's 8 of them. They're 1/8 of an inch. The B's are 1/4. There's 8 of them, 1/2 inch. All that. That's okay, but that's not very useful for the scenario I was painting before, where I'm just wanting to hand this off to the manual department to drill these at a drill press or at a Bridgeport. But one of the options I have down here is to set our locations relative to C, T, WCS, or world. And generally, if you're doing just 3-axis, these first 3 will do you just fine. Doesn't really matter which one you go for. I always tend to go for C plane. You can see now it's labeling each single hole with its own unique number here and letter, and it is laying out the location in X, Y, and Z. Now, in this situation, I probably wouldn't care about giving them the Z because this is a pretty simple plate. They're all through holes except for the counterbore. So I'd probably say display as 2D, and I would get rid of the Z coordinate out of all of this. But I can create, which is really nice. If I go into a top view and I get a good view on my solid here, I could scroll down and I have active reports. And if you guys are used to setup sheets, then this is probably going to look very familiar to you. But if I say create a report, it creates its own document with a picture of the solid and a chart of all that information of the diameter, the X and Y location, the diameter, the X and Y location. Of course, if I had my Z selected to show the Z, it would also show the Z locations of them as well. So again, I could just print this out, send it off to the manual department, and they can go about drilling those holes while I use the CNC, for other more important jobs. And to answer your question, Elliot, you can export this as an Excel. So if I save this as an Excel, now you may want to delete the picture if you're going to do it in Excel, and that would give you some more room. But yes, it will export to Excel, and then you'd have just a basic chart that you can send out. And that's the whole table. And if you wanted to, you could actually green check out of here, and you can keep this note here. You can move the note around, and then when I turn off that level, it gets rid of that information. But again, this would be a situation where I'd probably want to, give that active reports to one of my operators on the manual side and have them drill these holes out. We're going to move on to some more solid manipulation and surface manipulation. So I'm going to open up a file here. Going to talk about, here we go. All right, guys. So let's say our task right now is to plug these holes. We want to do a 3D operation on this feature, but we want to make sure that the tool doesn't dive down into one of these holes. Now, there's 2 main ways of making plugs. One, and each have each are determined by what kind of model you have. If you have a surface model, we're going to use something called Power Surface, which was introduced in about, I believe, 2019. Oh, I almost forgot to mention, hole table has been around for quite a while. I think before 2020, it was a C-hook. So if you do want to use hole table in an older version, it probably is still there. Probably needs a little needs to be brushed off, get the dust brushed off of it, but it is still there. It may just be a C-hook, and it's not in this gallery here. And of course, if you're having trouble finding it, just give us a caller and we can tell you where it is in that version. So anyway, for surface models, if we want to plug something, generally you're going to use what's called Power Surface, which was introduced in 2020, I believe. And for solids, you're going to use what's called Modify Feature. Now we talk about plugging holes with solids quite a bit in our 3D class. We do it quite a bit. I'm still going to do an example of that in this class, but right now I'm just going to focus on the surface model here. So this is a surface model. These are all individual pieces that are kind of put together like a house of cards. So what I need to do here is I need to plug these holes, but before I can do that, I got to make a new level to keep things nice and clean. I'll call these my surface plugs. And I got to create some wireframe with a surface plug. So I will say curve on one edge. I'll grab this surface, make a curve on this edge here. I'll do the same thing for the holes while I'm at it, for the little holes. So now I got that wireframe. And now to plug it, in the surface tab, we have what's called power surface. And then we chain those holes, and I can only do one at a time, unfortunately. Now, without doing anything, without touching any of the settings, I already have a pretty dang good plug. And the reason being is, by default, this tool is using the neighboring surfaces to dictate its curvature. So in this case, it's looking at the neighboring curved surface to determine how to maintain that curve. Now, of course, I could turn that off by turning off the use normals. And it starts getting a little weird, starts getting a little humped, because all it has to run off of is the wireframe itself, not any other neighboring surface. And of course, you know, I could really jack with this sucker. And this tool has a lot of great capabilities when it comes to design. But unfortunately, I only really use it when it comes to plugging holes, because that is hopefully the only time I have to deal with surfaces. But you can see there it's maintaining that curvature because it's using the neighboring surfaces to determine that curvature. But we could do other things, like we could extend it if we wanted to. Oh, it's probably not going to be extended because it's closed up. We can rotate the UV if we need to. Again, if you're not familiar with UVs, that's the kind of the grain of the surface. There's offset center, which honestly I don't know. I don't know what would be a good situation for that. But as you can see here, I can offset the center up, give it a little nipple. But don't really know a real world application for that. But maybe that's just because I'm not an engineer. We can change how it trims, all that fun stuff. But this is a very complex tool, but down in its roots, you can make it really simple for plugging holes. So I'll hit the blue check to move on to the next hole. That one's now plugged. Blue check, move on to the next hole. And there we go. All three of my holes are now plugged. So that's how you would plug holes in a surface model. But let me show you how we do it in a solid model. So I'll make another level. And in here, this is the solid. It's the exact same model, just solid form. And we don't need to create any wireframe. We just go up to Model Prep, Modify Feature. Excuse me. And we have the ability to create a body, which is a plug, or we have the ability to remove an entire feature. So if we wanted to remove this hole altogether, maybe because that hole's not supposed to be there, then we could say remove. So here, I'm going to go ahead and grab the inside of these holes. The one caveat with this tool is you got to make sure you grab all model or all faces of that feature you intend to plug. So if you have a little corner radius on the top here, you got to make sure you select that as well. We'll green check. And now you can see that that plug is following the curvature of that face. In my opinion, it's a lot less work. On top of that, this plug now has has mass to it. It's filling the entire space rather than just covering it up with a sheet. So you're not going to have surface normal issues. And if there was a bottom side of this, you're plugging the bottom side of that hole as well. On top of that, what we can do is we could do multiple plugs at the same time. So if I did modify feature, and I'm double clicking to select the entire feature, I just plugged all 5 of those holes at once. All right. So now I want to take some time to talk about direct editing, specifically push, pull, and move. So how push, pull works is you select a face or multiple faces, and it will expand or contract that face normal to that face. So in this case, I've selected the bottom of this floor here, top of this floor here. If I click on this arrow, and I'll put it into a isometric view to make it a little bit easier to see. If I grab this arrow, I'm now moving this face up and down. I'm pushing and pulling it up and down, normal to that face. I can also grab the side of this boss here, and when I grab a radius, I now can control the actual radius of that feature. So this is your quick way of editing holes. So if I say grab the inside of this hole here, I'll go to a top view and make it a little bit easier to see. Oop. Right-clicked on the ruler. I can make it bigger, I can make it smaller, just as long as it doesn't break the model. There we go, green check. Now that hole has been modified. Now something you got to keep in mind, guys, is that this direct editing tool requires the solid to not have a history. So if I drew these holes in Mastercam, doing this is going to give me a nasty warning saying, hey, in order to do this tool, you have to remove the solid's history, because we don't want to give it conflicting information about you telling it that this hole was extruded with an 1/8 inch hole, and then the direct editing is telling it, no, that hole is actually a 1/4 inch. Okay, so that's push-pull, but what is move then? Well, let's paint a scenario for you here, guys. Let's say I want to move this top feature down. I want to move this top feature down like 1/2 inch. Well, push-pull could do that. It's not going to do it cleanly. Watch what happens when I do a push-pull on this top face. So if I click on this face and I go to a top view to make it a little easier, or I'm sorry, a front view to make it a little bit easier to see, I grab this arrow. You can see now I'm modifying the radius of that top, which is not preferable. I don't want to modify the radius of this top feature. I want to modify the position of it. And whenever you want to modify a position of something, that's where move comes into play. So move is very similar in push-pull in a lot of ways. The difference is when you select one face or multiple faces, you are moving it in X, Y, and Z, not necessarily normal to that face. So in this case, if I go back to a front view and I grab the Y-axis, I'm now moving that feature down. I'm not actually editing that radius, I'm just moving that feature down. Now again, there are cases where push-pull or move will work for you here, but move is really great at, just as it says, moving a feature. So if I wanted to move this hole right here, let me go to the top plane. There we go. I can move this hole wherever I want, granted that it can actually still extrude through the body. So I can move the hole right here, green check, and there's my hole. So push-pull will let you modify a feature based off the normal of that feature, while move will let you actually physically move that feature wherever you need it. And again, both of those tools have been around for quite a while, but they require your solid to be dirty. And if you import a model from a different CAD system, like you import a step file, you import a Autodesk file, that file already does not have a history. So you're welcome to push-pull and play around with it all you want there. And with 2022, you can actually push-pull multiple solid bodies at one given time, which is new with 2022 there. In case you had a symmetrical model there. All right, guys, we're coming into the end, but I want to talk about two more files here. The first is going to be talking about hole template. So this was a little trick I found, or someone showed me a couple years ago when this feature was first introduced. And unfortunately, we, I guess, failed to pass that on to you guys to show you. So that's why I'm showing this to you now. So I got a really complex model. If you guys have seen our rollouts, you've probably seen this model pop up here and there. It's a really good, just busy model full of holes. And so if I look in my level or my solids manager, you can see here that this is just a dumb body. It doesn't have any holes defined. And what I'm going to do is I'm going to go to model prep and add history. I'm going to add history to this model. I'm going to say create operations, create hole operations. And since this is a metric part, I'm going to set the maximum radius to 200 millimeters. And I'll green check. And again, this is just a review from our rollouts, our last few rollouts, because again, this part pops up quite a bit. And this is where I'd show like, oh, hey, look, you know, we got all these different holes here. But let's say, for instance, that this hole right here, this green hole right here, you want to use that hole on a different solid. You know, someone's went through the trouble of drawing this hole up, and you don't want to go through that same trouble. You just want to use it on a different model. Well, first, let's identify which hole that is in this list. So I hit this little cursor icon in the solids manager. That lets me pick a feature, and that will identify it in the solids tree for me. So if I pick the inside of one of these holes, like this hole in particular, it says, okay, it's this custom hole right here. I then right click and hit edit as if I'm going to edit the dimensions. Give it a second. So you can see here, this is a custom hole that has all these different diameters, different tapers, all this stuff. It'd be, you know, a good few minutes for me to design this hole in Mastercam from scratch. But what we can do is this information's already in here. So I'm going to expand the templates. And usually I would use templates for sockethead cap screws or some standard size drill holes and other things. But we can actually create our own template in here. So I'll create a category with this green plus, and I'll call it stolen holes. I'll hit OK. This is empty. And now in this hole, I can just hit this green plus here, and I'll call it stolen hole number 1. Give it a second. It is now saving that information into that template. And now I can green check out of here. And if I wanted to, I could also grab another hole and save it in that template. I can grab another hole and save it in that template. Now, I always make it a point to save your file after you do that, just so it saves the template directory. You don't necessarily need to do this step, but I always like to, just to make sure. So I'll just call this test. You know, this isn't going to hurt the actual model. I just want to make sure that it saves everywhere in Mastercam, not just on the model there. So now I'll make a brand new file, and that was a metric hole, so it'd probably be best that I go back into a metric configuration. I'll go to solids, block, center, and I will say that it's a 100 millimeter by 100 millimeter by 200 millimeter. Make that negative. No, very simple. Now if I go in the hole tool and I expand templates, which is already expanded from the last time I was in here, I can now click in my categories. There's my stolen holes template category. I click on stolen. I click on a position. Enter. There's my hole. I didn't have to redraw it. I didn't have to go through the trouble of making this little hole piece by piece. The engineer already went through that trouble. I'm just stealing his work. And I can save as many as I want in here and have a whole slew of templates that I can pull from of different holes, different port holes, and among other things there. You can have as many holes as you want in here, and then, you know, just reference them as you need to. Because all it's really doing is just saving that information, what the hole size is, what the angles are, into that template. And with custom holes, it's just much, much more practical. All right, guys, the last thing I want to talk about today, because I know we are running a little bit low on time here. We got about 1 minute and 30 from our original time estimate here. But what I want to talk about last is something that's very hard to show. So I've done my best to break this model. So this model should look very familiar to that one I did for the layout. And what I did to try to quote unquote break it is I converted it into an IGES file and brought it back into Mastercam, converted it back into a solid, and that introduces what I would call errors. When I was tasked to do this design webinar, I really wanted to make a point to talk about repairing models. However, I was in a bind because every model I ran into where I've had to, that would have been a great example of this is when it's a good time to use Optimize. This is a good time when you simplify. Every time I came across a model, it was a customer model. And as part of our non-disclosure agreement with you guys, we do not share any of your customer files unless you explicitly tell us it's okay. And so what I did was I did my best to break this model as much as I can to kind of show this to you guys. But if you run into problems where you're getting a bunch of Boolean errors, you're getting a bunch of errors with the model, these next few tools I'm going to talk about are going to be your main lines of defense when it comes to trying to repair these models. So first, how do I tell that this model has errors on it? Well, I can click on the model, right click, and hit Analyze Entity Properties. And in here, there's a little check solid button here. If I click that check solid, it's going to tell me that I have total 167 errors. And it's only displaying me 10 at a time. And I can go as far as to click on one of them, hit this little zoom icon, and it's going to zoom in onto one of the errors. And you can see that this is some random edge from the back of my part that's having an error. So how do we go about fixing these errors? Well, the first tool we have in our toolbox is what's known as Simplify Solid, and that's in the Model Prep tab. It's called Simplify Solid. And this is going to be the least intrusive of the three tools I'm about to show you. What Simplify Solid is going to do is it's going to look for ways to make simplification. So if you look here, I have this top face split up into I think four pieces actually. Nope, three pieces. Really, this floor could be one big solid face. It doesn't have to be split up into three sections. So what Simplify is going to do, if I grab the entire body, make it a little bit easier on myself. Whoop. Green check. It tells me 8 redundant faces and 8 redundant edges were removed. So it's going to look for any redundancies that it can take out and therefore simplify my face. So now you can see here, there's no longer any edges on this top face. It just combined it into one face. And that's, like I said, the least intrusive out of the three tools I'm about to talk about here. That is just going to look for simplifications where it sees 2 fillets right next to each other that could be combined into one fillet. The next tool is my go-to whenever I'm having trouble with a solid, whenever a solid's not doing exactly what I want it to do. Whether that modified feature's not working, push-pull's not working. The next tool is underneath Simplify Solid, and that's Optimize. Now, Optimize is going to attempt to repair all those edge errors and attempt to repair those blends. It's also going to look for duplicate edges on top of each other, going to look for smaller errors like that. And when I green check, it's going to take a second. And it's going to say 50 optimizations were made, and it's going to do its best to highlight them. So everything that was highlighted, that's something that was optimized. A green check. And now if I analyze this solid the exact same way as I did before, I hit check solid, we went from 167 errors to 19 errors. And I've seen this do dramatic changes to the model, or not dramatic changes to the model, but dramatic improvement to the error count. Now you see here that didn't fix everything. And unfortunately, what I'd have to do to get these last few little pieces here is use the third and probably the most hands-on tool out of all of these, and that is repair small faces. And how this works is we pick the body and we set a tolerance. We set a tolerance for what is considered a small face, what is considered a small edge, what is considered a spike, what's considered a sliver, what's considered a gash. And it's going to do its very best to find them and repair them. The problem is this is actually manipulating your model. So if I say small edges and I open up this tolerance to like 1,000 and I hit preview, found 0 small, or it said it found 1 small edge. There it is. It found 1 small edge. It looks to be like in the center of the model. That's less than 1,000. Just really tiny edge. That was part of the issue. I can open this up a little bit more, and it's going to start identifying other small edges. And when I hit the green check, it literally removes those edges from the list. And if I analyze my solid again, we went from 19 errors to 15 errors. So we're slowly getting this model back up to speed. Unfortunately, you got to be really careful with repair small faces or remove small faces, because you are actually repairing those edges, and therefore you're adding discrepancies in that edge. So you gotta be really careful. I would not go into repair small faces and then immediately bump this tolerance up to 100 thou, because that's going to cause a lot of problems. It looks like it did find some small edges that it could repair. If I green check, it is actually manipulating our model at this point. Okay, so I removed a couple more bad edges, but you got to be very careful with opening up that tolerance, especially with the other tools there. So those are your three main lines of defense. Whenever I'm dealing with a really crappy model, whether it's from, usually the story is always, this is a scan from China. Whenever I'm dealing with a really bad model, these are the first three tools I go through. I go through Simplify, I go through Optimize, and then I'll try to do a repair, small faces. Generally, an Optimize will fix a good chunk of my issues, as you saw there before, but repair small faces is our way to getting down and dirty with it and trying to fix it on a step-by-step level. All right, guys, so that's pretty much all I had there. I know we went about 5 minutes over, but that's pretty much all I had prepared for the webinar. I had a couple more things, but it's they're very, very minor, so no biggie there.
Yeah, Devin, I think most everybody's still hanging out. If there's anything else you want to cover, we can do it. Or if anyone has any questions, we can answer those as well.
Yeah, I guess the biggest thing there, I just wanted to show, and we have already kind of talked about this in previous webinars, but just to kind of as a little refresher, in 2021, we added the ability to edit UV lines on surfaces. And again, it's a really quick one, and we've already kind of covered this before, but if you were trying to do a flow line down this surface, one thing you have to be mindful with flow line and flow and multi-axis is that it has to maintain the same UV lines, or the grades of that surface need to stay consistent. And in the surface tab, we have what's called edit UV and overflow UV. Edit UV is probably the main one you'll use, where you select all the surfaces you want to group together, and you can see here it's showing you the U and V of each one of these surfaces. I can then hit propagate and make all the rest of the surfaces match a particular set of UVs. And now Flowline will calculate a lot better. You can also go into overflow UV and manually rotate the UV lines. Or I'm sorry, reflow. Overflow is something different. Reflow, where you can manually rotate the UV lines. Overflow UV is new with 2022, and it lets you drape a surface on top of another. And if you're curious about that one, we do talk about it a little bit in the rollout webinar. All right, guys, I think that's all I got.
Appreciate everyone's time. Thank you for attending today. And if you have any questions, there's our contact info. We'll see you guys on the next webinar. Have a good rest of your day. Thanks, Devin.